Good morning, dear students. My name is Ferhan Mazher, and today is 25th of May 2021. Right now, I am with the O2 class. The subject we are studying is Physics 5054, and we are studying the chapter of current and electricity. This is basically O3 syllabus which we are trying to cover. And in this chapter, today, the topic this is the third lecture on this chapter. Today we are going to talk about electromotive force. Electromotive force is we normally call it EMF. EMF is the potential difference between the terminals of a battery. You see, the battery has a positive terminal, it has a negative terminal, and if you take a voltmeter, you remember that the voltmeter you use to measure the potential difference, the potential difference between the positive terminal of the battery and the negative terminal of the battery, that is called the electromotive force. And basically what happens, you see, the battery is a source of energy. In the battery has a chemical potential energy. Remember this word, the battery has a chemical potential energy. In the battery there are some chemicals, they react with each other and they produce electric energy. So the energy is provided to the charge particles in the battery. So we say that a battery basically has chemical potential energy, which is converted into the electric energy, and then the charges come out of the battery from the positive terminal of the battery, and they go into the circuit. So you see, the potential difference of the between the terminals of the battery is known as the electromotive force. It has nothing to do with the force, just its name is electromotive force, EMF. And it's actually its potential difference, its voltage difference, its potential drop across the terminals of the battery. Let me show you a diagram so you might be able to understand this more. For example, here, let me show you. Mhm. Yeah, here, if you want to measure the EMF of a battery, EMF of the battery means the potential difference between the terminals of the battery. You can see in the diagram that we have a battery, and that battery is connected with a voltmeter. A voltmeter has been connected with the battery, and this voltmeter will measure the the potential difference across the terminals of the battery. So this is how you will measure. If you directly connect a voltmeter with the battery, it will tell you the potential difference between the terminals of the battery. There is no resistor or component or appliance connected in the circuit. So this voltmeter is basically telling you the potential difference between the terminals of the battery, and this is called the EMF of the battery. We don't say the potential difference between the terminals of the battery. We have a word for this, and we say EMF of the battery. So EMF of the battery means EMF of the cell means, or EMF of the source of electricity means that what is the voltage, volt provided by that source. So, and one very important thing about the EMF is that when you have cells, um, we are talking about cells, and the source can be WAPDA also. WAPDA means the electricity which is coming in our homes, and we can connect. In your real life, you must have seen that this when you put cells, for example, if you have a torch or if you have a remote control, TV remote control, uh, you must have seen that we put more than one battery, or we put more than one cell in that those remotes, or in your toy cars. We put cells, but we put more than one cell. So there are different ways in which you can connect the cells with each other. And let's have a look at how you can connect the cells. For example, let me show you. Let me show you my work. So let me show you. So Here we have. Here a very simple example in which I will try to show that the cells, they are connected. The cells or the batteries, they can be, if you are using more than one cell or using more than two cells or three cells or four cells. So there are two ways in which you can connect the cells with each other. One is called the parallel circuit and the other one is called the series circuit. So when you connect the cells in the series circuit, so what happens? For example, here you have three batteries. So each battery is of 12 volt. This battery is its EMF is 12 volt. Its EMF is 12 volt. Its EMF is 12 volt. You see one thing which will happen in our syllabus, in O levels physics, the cells will be identical. It's very important because the questions which you will get in your exam, the cells will be always identical. So when you connect them, so here you can see we have a battery. It's a 12 volt battery. This battery is also a 12 volt battery. This battery is also a 12 volt battery. If I connect in such a way that the you see from, let's start from here. The positive of this is connected with the negative of the battery number 2. The positive of the battery number 2 is connected with the negative of the battery number 3. And the negative of the battery number 1 and the positive of the battery number 3 is taken out. So you see, if you connect the batteries in such a way that the positive of the one is connected with the negative of the second, the positive of the second is connected with the negative of the third, and from the negative of the first and from the positive of the last, you take out the connection wires, and you see you have connected the cells in series. So when you connect the cells in series, you see their EMF add up. So the total EMF or total voltage provided by this combination of batteries will be 12 plus 12 plus 12. So when you connect the batteries in series with each other, their EMF will add up. Another way of writing, or another way of connecting, sorry, another way of connecting the batteries can be in such a way that the negatives of all the batteries is connected with each other and the positives of all the batteries are connected with each other. Like in this combination, you see the negative of the third battery, the negative of the second battery, the negative of the first battery, they are connected with each other. And the positive of the third battery, the positive of the second battery, the positive of the third battery, they are connected with each other. And this combination, if you put the batteries or you connect the batteries in such a way, we say that you have connected them in parallel to each other. So if you connect them in parallel to each other, so you see what will happen. And the important thing is, in your syllabus, the batteries will be always identical. So their EMF will be same. So when you connect them in parallel to each other, so the EMF of the whole combination, the voltage of the whole combination will be equals to the voltage of the single battery. So when you connect the cells or batteries in series, there the EMF of the combination will be the sum of the individual EMFs. But when you connect them in parallel, and in our syllabus, the batteries will be always identical, the EMF of the whole combination will be equals to the EMF of a single battery. So I hope that you have understood. Let me show you more examples on it. So for example, here, this is a one way of writing the battery. The battery is represented with these lines. Remember this, these lines. One larger, longer line and one smaller line. So this larger line represents the positive terminal of the battery. This smaller line represents the negative terminal of the battery. So here you see I have three cells connected with each other. When I connect these three cells in this way, that their positives are connected with each other and their negatives are connected with each other. And then I take out the connections and I have connected it with, this is the symbol for a lamp, and this is an ammeter. So you see what will happen. EMF 1, EMF 2, EMF 3, and in our syllabus they always be identical. So now you see this combination is called parallel. They are connected parallel to each other. Why I am calling this? This is, they are parallel in a parallel manner. They are connected because the positive of all of them are connected with each other, and the negative of the three batteries are connected with each other. And then I have taken out the connection, and I have taken out the power, and I connected it with the lamp. So this is a parallel combination of EMFs, or batteries or cells. So in this way, when you connect the cells, the EMF of the combination of the cells, or EMF of the total combination, will be equals to the EMF of a single cell. So this is the way of connecting the cells or batteries in parallel to each other. Then let me show you another example. Uh, so let me show you. This is the ammeter. You see this diagram. If you look at this diagram carefully, here I have a. Let me show you. Here we go. So if you look at this diagram, you see here we have different cells. There are three cells. This is the positive terminal of the cell number one. This is negative of the cell number one. This is the positive of the cell number two. This is negative of the cell number two. Positive of the cell number three. Negative of the cell number three. So I have connected them in such a way that the positive of this is connected with the positive from here. I've taken out the connection, and the negative of the cell number one is connected with the positive of the cell number two. The negative of the cell number two is connected with the positive of the cell number three. And from the negative of the cell number three, I have taken out the the connection, and I have put a voltmeter across this combination. EMF1, EMF2, EMF3, these are the individual EMFs of these cells. When you connect them in series with each other, this is called series. So when you connect them in series with each other, you see the EMF of the combination will be equals to EMF1 plus EMF2 plus EMF3. So their EMF will add up. Okay. So I hope that you have understood. So this is how we do this, and let me show you another very good example. This was one example. I have a diagram, taken out a diagram here. Yeah, I was having very good. Yeah, here you see. Here you can see that in this diagram, I have tried to show. Here we have cells, the actual diagram of the cells. You can see here I have connected the negative of the cell number one with the positive of the cell number two. The negative of the cell number two is connected with the positive of the cell number three, and so on. You can put more. So if you put the cells in this way, this is called that. This is the you have connected them in series. So the EMF of the combination will be equals to E1 plus E2 plus E3. So this is how we do this. Okay. So this here you can see here we have connected the cells in such a way that the positives of the cells, they are connected with each other, and the negatives of these cells, they are connected with each other. And then I have taken out the connection. This is called the parallel. The batteries are connected in parallel to each other. And we always take identical batteries in this case, and the EMF of the total combination, the EMF of the total combination will be equals to the EMF of the single of the individual single EMF of a cell. So in the series, the EMF will add up, and in the parallel, the EMF will not add up. Okay. So let me go back to that where I was. So this is about the EMF, and so as a source of electromotive force converts non-electric energy, chemical, thermal, mechanical, etc., into electric energy. Examples of sources of EMF are batteries, thermocouples, and generators. When a conductor is connected to a battery, current flows through it due to potential difference. For the continuous flow of the current through a wire, battery supplies energy to the charges. The positive charges leave the positive terminal of the battery, passes through the conductor, and reaches the negative terminal of the battery. As a positive charge enters the battery at its lower potential point, negative terminal, the battery must supply energy, say W, to the positive charge to drive it to a point of a higher higher potential. For example, positive terminal. Now we define EMF of the source as. So the EMF of the definition of the EMF of of any battery or a cell is, you see, it provides energy. It converts in the cell. What happens in the cell? The chemical potential energy is converted into electric energy. So the amount of chemical potential energy converted into electric energy when unit charge flows through a battery, that is called the EMF of that battery. It is the energy supplied by a battery to a unit positive charge when it flows through the closed circuit. So the energy which the battery provides to the unit positive charge to make it flow through the circuit, that is called EMF. Or the energy converted from non-electric forms to electric form when 1 coulomb of positive charge passes through the battery. Okay, so in all hours we define it like this, that the amount of chemical, if I'm talking about the dry cell, the amount of chemical potential energy converted into electric energy when unit positive charge flows through the battery, or the work done by the battery to move the unit positive charge in the circuit is known as the EMF of the battery. This definition is very famous, frequently asked definition of 2 marks in the O-levels papers. So it's very important to remember this definition. Another very important thing is the formula. The EMF, the formula is the energy divided by charge. Is the same formula for the potential difference. The formula for the potential difference is also energy divided by charge. So E is equals to W by Q, where W stands for the energy, Q stands for the charge, and E stands here for the EMF. So EMF is measured in volt. It's the remember one thing. You see, we have studied 2 terms. One is potential difference, which I talked about in my lecture number 2 on this in this chapter. And today we are talking about the EMF. The both of them, the EMF of the EMF and the potential difference, they both are measured in the same unit. The unit is volt, V-O-L-T, volt, represented with capital V. The formula for the potential difference is also one formula for the potential difference. I can show you that. The formula for the potential difference is also the same. Here in this book, I don't have that formula, I think. The formula is also energy divided by charge. The formula for the potential difference is also energy divided by charge. The formula for the EMF is also energy divided by charge. Remember, energy is measured in joules and the charge is measured in coulombs. You see, the potential difference or the EMF, the unit used for them is volt, V. And this is a very frequently asked MCQ. The volt, the unit for the EMF is volt, and another unit used for the EMF will be joule per coulomb. J by J divided by coulomb. J per coulomb. Joules per coulomb. Joules for the energy and the coulomb for the charge. Okay. So whenever you want to, if you want to measure, for example, the potential difference across, for example, if you want to, the diagram which is showing up on your screen, if you want to measure what is the potential difference across this lamp, so I will use a voltmeter. So the voltmeter is always connected with the parallel to the appliance across which you want to measure the potential difference. So if you want to measure the potential difference across this bulb, so what I will do, I will put a voltmeter parallel. You see, parallel means I provided a separate loop for the current. So one terminal of the voltmeter is connected with one end of the bulb, and the second terminal of the voltmeter is connected with the second terminal of the lamp. And in this way, the voltmeter will tell you how much voltage is used, how much is the potential difference, how much is the voltage drop across this bulb. But if you want to find out the EMF, you don't put, you directly connect the voltmeter across the terminals of the battery. So in this way, you can find the EMF, and in this way, you can find the potential difference across the terminals of the battery. So one thing very important and frequently asked is, uh, let me show you another thing, very important. You see, here we have, let me show, let me clear the size. Okay, so volt is basically the, try to understand, volt is basically the unit for the potential difference. So if potential difference is, you can define the potential difference as the amount of electric energy converted into any other form of the energy when unit charge flows through a component. So that will be the potential difference. You see, the definition of the EMF and the definition of the potential difference, they are kind of same. But in the potential difference, I use the word, I say the amount of electric energy converted into any other form of energy when unit charge flows through a resistor, through a component, through an appliance. But in EMF, I kind of use the same words, but their order is different. In EMF, I say the amount of chemical energy converted into electric energy when unit charge flows through a battery. So definitions, they sound like same, but the conversion of energy is opposite to each other. In potential difference, I say the amount of electric energy converted into any other form of energy when unit charge flows through that component. But in EMF, I say the amount of chemical potential energy converted into electric energy when unit charge flows through the battery. So the potential difference is always across the components, across the electric components. For example, across the resistor, across a lamp, across a speaker, across a TV, across a fan, across a heater. So the potential difference term we use when we talk about those things which use electric energy. And the EMF term I use when I use it, EMF term is used for the potential difference across the terminals of the source of electric energy. You see, so there's a difference. And then these you can see, these are different kinds of batteries, cells, which we use in our daily life. And this is the formula. Voltage is also equals to energy divided by charge. Energy divided by charge. Work done divided by charge. The definition of the voltage is also energy divided by charge. The definition of the EMF is also energy divided by charge. The formula for both of them is same. Okay, so if you have the cells and I can connect the cells, you see, electric cells, if you have electric cells, you can connect them. If, for example, here I can show you, I will show you this. For example, here you can see I have 1.5 volt cell, 1.5 volt cell. I'm talking about this diagram. 1.5 volt cell, 1.5 volt cell. I have connected them. The cells, the two cells have been connected in the circuit diagram. In you can see, and they are connected correctly. So what will happen? Their EMF will add up. The negative of the first is connected with the positive of the second, and we have taken out the connections. So 1.5 volt, 1.5 volt. The total EMF of this will be, this combination will be 3 volt. And here in the B diagram, you see the negative of the first battery is connected with the negative of the second battery. That's the wrong connection. This is not the correct order of connecting the cell. The negative of the first should be connected with the positive of the second. Then they will add up. Then their EMFs will add up. Then their voltages will add up. Then there's the cells. They will help each other. They will, their EMF will sum up. But if you connect it like this, the negative of the first is connected with the negative of the second, and you try to take out the connection, the cells are connected in the wrong order. So the EMF will be zero. Here you can see the positive and the positive, they are connected with each other. The negative and negative are connected. If when you put the cells in this way, this is called a parallel combination. And in the parallel combination, the total EMF or the total voltage of this whole combination will be equals to the voltage of a single cell. So a single cell here is 1.5 volt. So the total voltage of this whole thing will be 1.5 volt. So you can read this article also. This is showing up on your screen. You can stop the video and you can do your reading. Okay. So whenever you want to measure the voltage, remember here I am trying to show you a circuit diagram. If you want to measure the voltage, for example, if you want to measure the potential difference across this lamp, so what you will do, you will use a voltmeter, and the voltmeter is, remember, is always connected parallel to that component across which you want to measure uh, the potential difference. So if you want to measure, for example, here you can see, if I want to measure what is the voltage drop across the lamp 1, I will put a voltmeter parallel to the lamp 1. If I want to measure what is the potential drop across the lamp number 2, so I will put a voltmeter across the parallel to the lamp number 2. So when you connect the cells in series, so the voltages will add up, and when you connect the cells, here one thing is very important. You see here I have provided 1.5 volt. This is about the potential difference, not about the EMF. The voltage drop here, the voltage drop here, the voltage drop here, the voltage drop on each lamp. When you add up, that will be the voltage drop of the EMF of the battery. So if 4.5 volt is given by the battery, some voltage drop will happen here, some voltage will be used here, some voltage will be used here. When I will add up the individual voltages, that will be equal to the voltage of the battery. So but one very important thing here, the lamps, they are connected in parallel to each other. We have not yet studied connecting the lamps in parallel, but here the voltage drop across the lamp number 1 will be equal to the voltage drop across the lamp number 2, and that will be equal to the voltage of the battery. This we have not yet studied. This is the combining of the lamps in series parallel to each other. Okay, so this was it. One last thing I want to tell you, which is very important about with respect to the EMF. You see, when I connect the lamps in series like this, or I can choose the other diagram, and let me show the other diagram. I have that diagram here. Where's that diagram? For example, so when I connect the cells in series with each other, their EMF will add up. That's the last few lines which I want to say. Their EMFs will add up. So when the EMFs will add up, so you will have a larger EMF of the combination. So that's a benefit. And but what happens when you connect them in parallel? When you connect them in parallel, the cells are connected in parallel. Their EMF, the EMF of the whole combination is equal to the EMF of a single cell. But what is the basic advantage of connecting them? You see, when you connect the cells in parallel to each other, if one of them dies, if one of them runs out, the rest of them will keep providing the electric energy. If one of them dies, one of them runs out, one of them is exhausted, so the rest of the cells will keep providing the electric energy. That's a big advantage. When you connect the cells in parallel, their life becomes longer. When you connect the cells in parallel to each other, their life becomes longer. They last longer. Their life becomes longer. And this is a very famous question, frequently asked in O levels exams, that what's the benefit of putting the cells or batteries in parallel to each other? So hopefully you have understood. And today's main topic was about the EMF and how we can measure what is EMF and how we can measure the EMF. And EMF is basically potential difference across the terminals of a battery. And then we talked about the potential difference, and little bit about the potential difference also. And then we also talked about the difference between the EMF and the potential difference, the definition of both these potential difference and the EMF. They are very important. They frequently come in exams. And then we learned about the EMF of the combination. If you put the cells in series and if you put the cells in parallel to each other, so what will be their combined EMF? So hopefully I have tried to explain what is EMF. Okay, electromotive force. It is actually the potential difference across the terminals of a battery. So I think it's enough for today, and so thank you very much, everybody, and hopefully you have understood it. So thank you very much, and have a good day, and God bless.